This is a riverbed in western Colorado in May 2026. Summer hasn't officially arrived, yet the mountain valley is already experiencing the kind of water scarcity usually reserved for the height of July. The statistics across the state show the scale of the problem. 97% of Colorado is currently classified under moderate to severe drought conditions. In the Eagle Valley, the local impact is immediate. The town of Eagle is holding at Stage 2 water restrictions to manage its limited supply. Just a few miles away, Minturn has moved to a Stage 3 water emergency, a drastic step taken to protect what remains of the local watershed. The dry landscape is already fueling fires. State crews are battling blazes in desiccated forests months before the traditional start of the fire season. This mirrors a national trend. Early wildfire activity has reached a 20-year high, with more than 1.8 million acres burned across the country before the summer heat has even set in. Usually, this level of moisture depletion is not seen until late August, but here in 2026, the region has completely exhausted its water reserves before the hot season has even begun. To find the cause of the dry valleys, we have to look to the high alpine peaks, which serve as the primary source for the region's water. These mountains function as a natural water bank. Colorado relies on winter snow to freeze and store moisture at high altitudes, which then melts slowly to provide a steady spring runoff. This chart shows the historical median snowpack. The bottom line represents the winter of 2025 and 2026, where accumulation stayed at the 0th percentile, the lowest levels ever recorded for the region. The problem is best explained by snow water equivalent, or SWE. This is a measure of the actual liquid water held in the snow, calculated by multiplying the snow's depth by its density and dividing by the density of water. Because the winter was the warmest on record, the base snow depth suffered its earliest meltout in history. By March 31st, the foundational snowpack had vanished completely. This makes the late-season storms in April and May deceptive. While they brought heavy, wet snow with a dense 5-to-1 snow-to-water ratio, they arrived too late to rebuild what was lost. These storms provided a visual layer of white on the peaks, but they couldn't replace the missing months of accumulation that usually sustain the spring runoff. A few late-season storms cannot mathematically make up for a winter of missing snow. The supply line from the peaks to the valleys is effectively empty at the source. As we follow the path of that missing water down into the canyons, the impact on the summer environment becomes clear. The projections for the coming months are stark. With the water content in the snow at less than half of the historical median, stream flows in the Colorado River Basin are expected to drop to 45% of their normal volume. This low volume causes water temperatures to rise, making it difficult for local trout species to survive in the warming rivers. This ecological pressure threatens the region's billion-dollar trout angling industry, which depends on the steady flow of cold, high-altitude water. On land, the lack of soil moisture has forced the state to adopt a permanent year-round fire strategy for the first time. Fire crews are now using multi-mission aircraft to track heat signatures and spot ignitions early, an essential tool when the forest fuels are this dry. The 2026 drought is the physical result of a water cycle that never fully began. Without the winter snowpack to feed the rivers, every gallon that remains is a choice between the needs of the towns, the forests, and the ecosystem.